We can simplify expressions involving polynomials by eliminating parentheses and adding like terms. For example, I have the binomial 3x plus 2 minus the binomial 2x plus 4. If I distribute my negative sign throughout the second set of parentheses, I would have 3x plus 2 minus 2x minus 4. If I add like terms, 3x minus 2x is x, 2 minus 4 is negative 2, and I simplified the expression to x minus 2. Or if we have values in front of the binomials, like in this example, 4 times the binomial x squared minus 6 plus 2 times the binomial x plus 4, I can distribute the 4 and distribute the 2 and then add like terms. Can't combine anything with 4x squared or with the 2x, but I can combine the negative 24 plus 8 to get negative 16. We may also have multiplication of binomials. Here I want to multiply these two binomials. I can use the FOIL method first, outside, inside, last, to make sure that I combine every term in the first binomial with every term in the second binomial. If I multiply the first terms, the 5x times 2x, I get 10x squared. If I multiply the outside terms, 5x and 3, I get 15x. If I multiply the inside terms, negative 4 times 2x, I get negative 8x. And if I multiply the last terms of the binomials, negative 4 times 3, I get negative 12. Combining like terms, I have 10x squared plus 7x minus 12. The FOIL method is really the same thing as just taking every term in the first expression by every term in the second one. As another example of this, what if I had the expression x minus 5 quantity squared? I'm taking the binomial x minus 5 and squaring it. Be careful in this case not to just take x squared and 5 squared. It might be more helpful though, or instead, to expand x minus 5 quantity squared into x minus 5 times x minus 5, and then carrying through with the FOIL method. X times x is x squared. X times negative 5 is negative 5x. The inside terms of negative 5 times x would be negative 5x. And negative 5 times negative 5 is positive 25. Adding like terms, adding the middle terms, in this case I get negative 10x for the middle term. Notice that we would not have had that middle term had we just squared the x and squared the 5. So it's best to take some polynomial to a power and expand that polynomial, or expand that expression. We can even multiply trinomials or polynomials of any number of terms. In this case, x plus y minus 2 times x minus y plus 3. I won't really call this the FOIL method because we have more than just first, outsides, insides, and last terms, but I still can carry through with the multiplication by taking x times each one of the terms in the second trinomial, and then y times each one of those terms, and then negative 2 times each of the terms in the second trinomial. X times x is x squared. X times negative y is negative xy. X times 3 is 3x. Now I can take y times each of the terms in the second trinomial. Y times x is plus xy. Y times negative y is y minus y squared. And y times 3 is 3y. And then I can multiply the negative 2 times each of the terms in the second trinomial. Negative 2x. Negative 2 times negative y is plus 2y. and negative 2 times 3 is minus 6. Collecting like terms, I have an x squared. The negative xy and positive xy subtract out. 3x minus 2x would leave me with plus x. 3y plus 2y would give me 5y. Minus y squared, nothing to combine it with. And minus 6, nothing to combine it with. And here's my expression. Notice that the terms don't have to be in this order. They can be in a different order as long as we have the correct signs in front of the terms. Let me give you a few practice problems. Here's the first problem. Pause the video, simplify, and then come back to check your answer. In this problem, if we distribute the negative 2 throughout the first set of parentheses, we have negative 6x plus 8. Distribute negative 5 through the second set of parentheses, minus 10x minus 5. Combining like terms, we have negative 16x plus 3. The second practice problem, 4x minus 6 quantity squared. Work this problem and then come back to check your answer. In this problem, it's probably best to expand 4x minus 6 quantity squared into 4x minus 6 times 4x minus 6. Multiply 4x times both terms in the second set of parentheses. 4x times 4x is 16x squared. 4x times negative 6 is negative 24x. Then multiply negative 6 times both terms in the second set of parentheses. Negative 6 times 4x is negative 24x. Negative 6 times negative 6 is positive 36. Combining the two middle terms, I have 16x squared minus 48x plus 36. And the third example, or third practice problem, x squared plus 2x plus 2 times x squared plus 4x minus 1. Pause the video, work the problem, and then come back to check your answer. In this problem, be very careful to take each of these three terms in the first trinomial times every term in the second trinomial. I'll multiply x squared times each of these three terms. X squared times x squared is x to the fourth. X squared times 4x is 4x cubed. X squared times negative 1 is negative x squared. Then let's multiply 2x times every term in the second trinomial. 2x times x squared is plus 2x cubed. 2x times 4x is plus 8x squared. And 2x times negative 1 is minus 2x. Then let's multiply 2 by every term in the trinomial, the second time trinomial. 2 times x squared is plus 2x squared. 2 times 4x is plus 8x. And 2 times negative 1 is negative 2. Notice I'm taking 3 terms times 3 terms. I have 9 terms before I simplify, which is 3 times 3. Collecting like terms. X to the fourth. Combining the cubes, I have 4x cubed plus 2x cubed, which is 6x cubed. Combining the x squareds, I have negative x squared plus 8x squared would be 7x squared, plus 2x squared is 9x squared. Combining the x's, negative 2x plus 8x is plus 6x, and then negative 2 has nothing to combine it with. So the multiplication of these two trinomials comes out to be x to the fourth plus 6x cubed plus 9x squared plus 6x minus 2. Remember, when we're simplifying expressions involving polynomials, to eliminate the parentheses and combine like terms.